Welcome to everyone that's attending tonight from right across the world. We've got people from the USA, from the UK, from Portugal, Europe, and all over. We've got some from Africa, but most people are from South Africa in this talk. Welcome. And a special mention to the Dias Cross Bird Club, which is Adrian's bird club, as well as my bird club. This is the coastal branch. They logged into our webinar on a big screen in the hall. So welcome. It's good to have you tuned in. I'm Lynette Rudman, and I'm coming to you live from Grahamstown in South Africa. This webinar is being recorded and it will be posted on our YouTube channel, the Learn the Birds channel, in a few days' time. Please post any questions or interesting comments in the comment section below, and Adrian will answer your questions. Now, we have a very special guest speaker, Adrian Craig. I've known Adrian for many years. We've been in the same bird club. And Adrian is a real bird expert. He knows his stuff. He's a retired professor of zoology, and he spent his working career lecturing at Rhodes University here in South Africa. Adrian has given many talks to bird clubs and school groups and other clubs. And he's even done a webinar for Learn the Birds last year on honey guides and honey hunters. And it's on our YouTube channel if you want to see it. It was an extremely interesting talk. I learned so much about honey guides. Adrian's research has always focused on African birds, and it's involved field studies, museum specimens, and studies of historical records of birds. And apart from his formal scientific publications, he has written many popular articles for birding magazines. He's contributed to handbooks such as The Birds of Africa, as well as the Handbook of the Birds of the World. So he's very well published. Adrian, tonight your talk is about such an interesting topic, bird migration, and where do the birds go? I know long ago people used to see the birds vanish when the weather turned cold and they had no clue where they had gone. And suddenly they arrived back in spring. So there were all sorts of theories. People really didn't know. So we're really looking forward to your talk. Over to you, Adrian.
Right, thanks very much for the introduction, Lynette, and welcome to everyone. I would like to focus on just two topics tonight, looking first of all at where these birds go. This map which you see here comes from an old edition of National Geographic, and it focuses, as one would expect, on Africa in the center, showing particularly the sort of African and Asian routes, and giving some idea of the diversity of birds that undertake these long journeys every year. So tonight I'd like to try and deal briefly with some idea about where the birds go, in particular about what we've learned about what individual birds are doing on these trips, and then look a little bit about navigation, how they find their way, because this is an interesting example of the way in which science sometimes fumbles along, gets stuck, goes down blind alleys, and very often advances are related to developing new techniques, new skills, but also new equipment, which enable us to do different things. First of all, sorry, we've skipped a bit. A reminder of migration in birds is a return trip between the breeding area and the non-breeding area. This gets us away from the problems with seasons, winter and summer, because some birds, of course, move within the same hemisphere, so it's not necessarily a change of season, but some birds move extraordinarily long distances. And it's a return trip undertaken by the same individuals. There are other animals which migrate, and interestingly, some of these are even insects. Here we have movements that occur across the Indian Ocean involving dragonflies, where dragonflies from India pass over islands in the Indian Ocean and land up in East Africa. And later, other dragonflies, not the same individuals, take advantage of different wind patterns to cross back from Africa to India. But the birds we're going to be dealing with, of course, it's the same individuals, and they may make many journeys during their lives. So first of all, a little bit of history. We have all heard of some of the early observations by, for instance, Linnaeus, who was famous for developing the naming system that we still use for animals and plants. Now, Linnaeus was a very distinguished botanist. His particular area of expertise was the flora of Lapland in Scandinavia, but he had very strange ideas actually about bird migration. Below Linnaeus's picture, you can see a collection of barn swallows. And many people in Europe were, of course, familiar with barn swallows because they often nest on buildings around people. And they would have seen them for the last time, probably flying low over the water, collecting insects before they set off on migration. And then they would disappear and suddenly would reappear again the following spring. So Linnaeus actually supported the rather bizarre idea that these birds dived into the water, hibernated underwater, and then re-emerged again the following year. Now, this doesn't make a great deal of sense in biological terms, but it's just say he was a much better botanist than he was a zoologist. At the same time that Linnaeus was suggesting this rather bizarre explanation for the swallows, another botanist, Michel Adanson, spent several years in Senegal in West Africa. He was a very fine botanist. He has the baobab tree, Adansonia, named for him. And he was clearly a very good naturalist. Unfortunately, he doesn't seem to have been particularly interested in birds. In his book on his years in Senegal, he devotes just 8 pages to dealing with the bird life. He also collected shells, and he spends more than 40 pages talking about his shell collection. But just in passing, he noted that the swallows and the European bee-eater, which he knew from France, were present in Senegal during precisely the months they were absent from France. And his conclusion was that these were clearly the birds from France who had migrated southwards to Africa and were present there during the time when they were absent from their breeding sites. This would all, of course, have been in the same hemisphere because it was still north of the equator. Some of the first direct evidence came in the 19th century. This unfortunate stork, shown in the left in a contemporary illustration, on the right, actually the museum specimen, which is still in the Rostock Museum in northern Germany. This bird got shot with an arrow, a very large arrow, and somehow managed to fly all the way back to Germany. It was then duly collected as a curiosity and ended up in a museum. But comparing the arrow to material that had been collected from Africa, by anthropologists, people concluded that this stork had been in the Sudan, which was where arrows of this type were used by local people. So there was some direct evidence of where individual birds might actually go. But the first big breakthrough came with bird ringing, which was established in Europe in 1899. In 1948, the first birds were ringed in South Africa. And it depends on a unique ID number assigned to a particular bird, and obviously international collaboration by different ringing units. And this goes far beyond normal international interactions. During period, for instance, when South Africa did not officially communicate with Russia, this was many years ago under the previous apartheid government. Every year, the Russians sent a large file of South African ringed birds recorded in Russia to the British Museum, who then forwarded it to South Africa, and the South Africans reciprocated by the same route. And when official relations were reestablished after 1994, one of the first things that happened was that Russian ornithologists invited South Africans who had ringed many Russian migrants in South Africa to join them on a field trip in the breeding grounds. From an individual point of view, we can use color ring combinations to identify individual birds. This requires the use of several rings if you're going to ring large numbers of birds. And there are problems because the colors fade over time and the birds can lose one ring, which then makes their combination ambiguous. So what has proved very much more successful being what we call alphanumeric rings. As you can see on this little bird, it has a single letter. In this case, the ring is not very well positioned, but if your eyesight is good, you can work out that it says S6. So a single number and a single letter. And these can be read through a telescope, and with modern photographic equipment, they can be photographed. So this has been highly successful because in Europe, there are many people who go out with powerful telescopes to watch birds, and they can then record sightings of individuals. But this still tends to focus attention on where the birds start out and where they fetch up, but not about the route in between. So here's the barn swallow, which has, as you can see, a huge breeding range across North America and Eurasia. The North American birds go south to South America. The Eurasian birds go south into Africa, into tropical Asia, and the Australasian region, including Northern Australia. The diagram to the right shows ringing records for European swallows found in South Africa. And we can see that they come quite a lot from the UK, where there's a very active ringing community and where the chances of birds being found is quite high, but also over a very wide range of Europe and right out into Siberia. There are birds which have moved between the eastern part of the range and South Africa. Before I go any further, and before anyone thinks that I have taken a lot of rather good bird photographs, I'd like to pay tribute to my friend and colleague, Warwick Tarberton, seen in the bottom corner of this picture. Warwick has very generously over many years allowed me to use any of his slides to illustrate these sort of talks. As you will see, he's a very fine photographer, and the great majority of the pictures of birds, which I will show here, were taken by him, and absolutely none of them were taken by me. Another bird for which ringing gave us first clear indication of dramatic differences between populations was the white stork. Here, it soon became clear that there were two distinct groups breeding in Europe. There were eastern storks who flew eastwards and then through over the Middle East down the Nile Valley, and these were the birds who fetched up in eastern and southern Africa. And there were western storks who crossed primarily at the Straits of Gibraltar, the narrowest crossing point. Some of them actually stop off in Spain, some go to North Africa, but the birds which turn up in West Africa come from this population. And it soon became clear that this was an inherited characteristic, that eastern storks, their offspring, would always migrate along the eastern route. Storks, because of their style of flight, the way they soar, avoid crossing large areas of water because then they have to flap actively, and it's much more efficient from their point of view to soar without using much wing movement, and this works only over land. So they minimize water crossings as far as possible. Now, once we had satellites circling the Earth, it became possible to prepare tracking devices which would transmit information to satellites. Initially, these were relatively heavy. The idea at that time was that they should not be more than 7% of the bird weight. They were costly. And then there are additional charges for downloading the data from the satellites. So this was an expensive activity. It was only really engaged in where there were considerable conservation issues at stake. So the European stork, which at one time showed dramatic population declines over much of its range, particularly in Western Europe, was an obvious focus of this. There was also the problem that you could only use these on relatively large birds. So here on the left, we have an early example of tracking a stork from its breeding site in Germany to Africa. You can see the line going down as was indicated in the earlier diagram, through the Middle East, down the Nile Valley, and then to southern Africa. And it's starting to return. At that point, the equipment failed, but later there was more success. I'd like to talk briefly about a particular stork known as Prinzesschen, which in German is little princess. This name was given to it by the local schoolgirls, and she became quite famous. I met Dr. Katz, who had worked on this particular project for many years at a conference, and we got into conversation, and his map showed that the previous year, Prinzesschen had spent a bit of her summer near a town named Mossel Bay in South Africa. So I pointed out that I'd actually been born in Mossel Bay, and he was tickled by this and photographed me next to the poster, and subsequently kept me updated on her movements. Now, I mentioned earlier how we have eastern and western storks. Prinzesschen was an eastern stork, so she followed the route you see there, but her partner was a western stork, and he went to Spain in the non-breeding season. So consequently, he had a much shorter trip to get back to the nest site. Prinzesschen became a bit of a TV personality. She had been filmed both in Germany at the nest and in South Africa. And when she was due back that year, 2002, they sent a TV crew to the nest site to await her arrival. They were rather surprised to find that clearly her partner had got bored waiting for his regular mate to get back from Africa, and he had a new female on the nest and a clutch of eggs had been laid. So they waited in suspense to see what would happen when Princess Yin returned. Well, there was a tremendous fight. The new female was driven off. The eggs were thrown out, and a rather chastened male accepted back his original partner, and they successfully raised the clutch of eggs again. So here we can see tracking records for Princess Yin. She died in 2007. Her body was found with all equipment in the Free State in South Africa, and it's thought she died of natural causes. There was no indication of a collision or anything else. She had been tracked for 21 years at that point. Now, the blue dots on this map show her southward migration, and you'll see that she followed the expected route, where she went out over the Middle East, down the Nile Valley, and then spent quite some time in the Sudan, even drifting across the Central African Republic, then headed south again, spent some time moving about between Zimbabwe, Botswana, and Namibia, and then finally headed south to South Africa. So she spent significant amounts of time in a number of different countries where she wasn't just in transit. And clearly this is important in terms of conservation. We need to know where these migrants are going and where they are spending time. And it's become clear that individual birds follow quite a consistent route and tend to make stopovers, often quite lengthy stopovers, in the same regions, which are presumably familiar to them. They know good foraging areas and so on. Then when Princess Yin headed home, she did this much more rapidly and directly. You can see from the dates there refer to her homeward, northward migration to the breeding area. She left South Africa, was still in South Africa on the 3rd of March. By the 3rd of April, she was in the Sudan. And by the end of May, she was back on her nest site. So a much more direct route. And this again seems to be typical of the pattern for many migratory birds. Heading to the non-breeding areas, they often make extended stopovers in different places. But when heading back to their breeding sites, they tend to fly more rapidly and more directly with much less stopover time. Another bird which is big enough to be suitable for satellite tracking is the bird known as godwit, which in southern Africa is not an especially common migrant visitor. On the map down below, you can see the hatched areas show the breeding range of the godwit, which is right across northern Eurasia and then into Alaska and even close to the Canadian border. So a very wide range of tundra areas in the extreme north. Then the non-breeding range is in part just in Western Europe, not that far, but also all along the western coast, particularly of Africa, Red Sea, and as you can see, all around the Asian coastlines and in Australia and New Zealand. And the Australians and New Zealanders were particularly interested in the migration route of this bird, and more recently, there's been satellite tracking of this species. So here we see what happens when the bird's going north. And you can see there were 2 sites in New Zealand where birds were fitted with appropriate packages, and 1 in Australia. And all of these birds headed north the Australian birds more or less due north, and they made an extended refueling, one would say stopover, in the Yellow Sea region on the coast of China. So this is clearly a key area for the species because they refuel at that point. In both cases, the Australian and New Zealand birds, they stop over very little before they reach the Yellow Sea region. They're flying over regions where there are islands, but in many cases, they're making extended direct flights. Godwits are not able to land on water, so they can only land where there is a coastline and dry, well, wetlands available to them. The Australian birds, shown in blue, then head north into northern Siberia to their breeding areas. But the birds coming from New Zealand are the Alaskan population, and they then fly straight across the northern Pacific to their breeding grounds in Alaska. What is much more dramatic, though, is when these birds fly south. The godwits from Siberia, again, go via the Yellow Sea region and straight south to Australia. The birds from Alaska, however, fly straight across the Pacific to New Zealand. Following these birds by satellite tracking has shown that some individuals will fly for 11 to 12 days non-stop because there is nowhere to land. There are only a few scattered islands, and these don't have very much to offer until they reach a larger section of coastline. So they will cover more than 11,000 kilometers non-stop, flying fairly steadily, but covering about 1,000 kilometers a day. And you need to get your navigation right, because if you miss New Zealand, the next landfall is Antarctica, which is not where you want to be unless you're a penguin and fairly specially equipped for conditions there, certainly not if you're a godwit. So this showed that different populations can show very dramatically different patterns of migration. The Yellow Sea region is important for both populations at certain times of year, but for the other population, only for the New Zealand population, only on southward migration, on northward migration rather. There's also been some satellite tracking in Africa. Wahlberg's eagle is a small eagle which comes in two color phases, beautifully illustrated by this slide by Warwick. You do find pairs, which are pale phase and dark phase. They don't appear to have any particular preferences for which color phase they mate with. And this was a study done by a combination of Namibian and German scientists, where they looked at birds breeding in Namibia. And here the pattern was of a much more rapid migration. So going north, this particular bird left its nest site at the end of March in 1994. By mid-April, it had passed the Congo River and was over Congo Brazzaville. And by the end of April, so virtually 5 weeks since it had left Namibia, it was in its non-breeding region, which was northern Cameroon, northeastern Nigeria, and adjacent Chad, where it spent its time in quite a narrow belt. It then headed south again in mid-August, or late August really, 19th of August, first date, and by the end of September, again about 6 weeks travel time, it was back on its nest site in Namibia, where it remained for several months. So in this case, the bird was spending relatively little time at any of the stations en route, and it went pretty directly, following exactly the same route in a very narrow band on both northward and southward migration. There are Wahlberg's eagles over a wide range in southern Africa. We even had a pair who must have overshot and turned up for the first time ever in the Eastern Cape, nested here for a few years. Then, unfortunately, only one bird returned, and since then, that nest site seems to have been abandoned. So there we have some examples of very spectacular journeys, but journeys which show very different characteristics in different species. So what about the smaller birds? A possible technique there employs measuring day length. This uses little devices called geolocators. These are very small. They weigh less than half a gram, and consequently can be used really on very small birds. They're also much cheaper than a satellite tracker. The downside is that you have to retrieve it to download the data. These are effectively little computer chips, one might call them, which are recording sunrise and sunset times along the route. So you do have problems when they are flying under completely overcast conditions. You may not get recordings on certain days. And you're then basing their location, locating the bird on a map by records of day length at different latitudes. This means that the location accuracy is limited. It's not as precise as GPS measurements and so on. And it's worse near the equator, where day length differences are very small, and it's also often not good at very high latitudes. But it has provided some very interesting information. Here we have a little 25-gram bird, the Eurasian wheatear, and this has a very interesting breeding distribution. As you can see on the map, the brown breeding range includes Alaska and a little bit of extreme Western Canada. Then there are populations on Greenland and bits of Eastern Canada, and then a huge range across Eurasia, right across to Siberia, the Bering Peninsula joining Alaska. But all the records of non-breeding birds are from Africa. And most of the records come from Western and Eastern Africa. It's one which only occasionally strays south into Southern Africa. So this is quite a contrast to the map, for instance, for the barn swallow, where the North American populations head due south to South America, whereas the Eurasian populations head south to Africa and Asia. So the question arose, what are these populations doing? And here geolocators were used and came up with an extraordinary result. The birds from Alaska, seen on the extreme east of this picture, on the right-hand side of the map, they fly all the way across the Bering Strait and right across Eurasia. Most of them fetch up in Eastern Africa. But the birds from Eastern Canada, which is where they got a few tracked, fly across the North Atlantic to the British Isles and then head due south, and most of them fetch up in West Africa. A few do move to other parts of Africa. Now, we've known for a long time that many migrants, particularly small birds which lay up stores of fat show a very marked circannual rhythm in their behavior. And this means that if you're keeping these birds in a laboratory under constant conditions, they show periods of what is referred to as migratory restlessness, or Zugunruhe, the German term is often used in the literature, at appropriate times of year. And they also go through a phase of laying up great loads of body fat prior to migration. So their whole physiology changes. They eat extra and store it as fat. Some small birds actually double their body mass before they leave. Small birds can actually do this. They can carry very large amounts proportionately of extra weight, whereas large birds can't. So eagles can't fly off with small children. The prey is too heavy. They can kill quite large prey, including small antelope in many cases, but they can't carry these off. That's just a sideline. So if you put Canadian birds and Alaskan birds in the laboratory and then observe them over their annual cycle, you find that the Canadian birds go through a phase where they will fatten up in preparation for migration, but the Alaskan birds don't. So there's a basic physiological, inherited physiological difference between these populations. The Alaskan birds are flying overland effectively all the way, except for a very short sea crossing. So they're feeding as they go. Whereas the birds which are crossing the North Atlantic have to lay in supplies for this sea crossing. Here's another example. This is a little bird which I came across an interesting paper on it, and I've never actually seen it, but it really does look like something which a child was asked to illustrate and given a pot of paints, and they tried to put as many colors as possible on the bird. Very beautiful little seed-eating bird, and as you can see, a very small bird. Now, in North America, there are two breeding populations, Eastern and Western. The Western population is the larger. The Eastern population is in trouble from a conservation point of view because the areas where the birds breed are along the eastern coast, which is heavily populated, lots of habitat change, and they're then flying south to Florida, where you can see the brown areas on the right-hand side of the screen, where some of them drift into the Caribbean, but these are also areas where major habitat changes and so on are underway. So the eastern population is declining. Here, geolocators were again used, and these showed very clearly that the two populations move in quite different ways. And there appears to be absolutely minimal interchange between the two areas, which is also supported by ringing data. So looking at the Western population, the birds from Arkansas seem to head more or less due south along the Gulf of Mexico and then fetch up in the breeding areas, the non-breeding areas along the Yucatan Peninsula, from southern Mexico into adjoining countries, Honduras, and so on. But the birds from a bit further west, from Oklahoma, will fly to northern Mexico, and there they hit a favorable period, if they get their timing right, of monsoon rainfall, where there's lots of food for them. They undergo a complete molt at this point. So they replace all of their plumage, so have an extended stopover before they then head southeast to the main non-breeding area. So once again, the important areas are, in this case, the breeding areas. For some of the population, this molting area in northern Mexico, where they have an extended stopover, and then the non-breeding areas over a much wider range and along the Peninsula. They were quite lucky here. They used 500 geolocators, so that's still a considerable outlay. I can't resist showing another picture of this extraordinarily colored bird. And they recovered a quarter of them, which is quite good going. I read of a very sad study in Germany where on a small warbler, they had identified a population where there was a very high return rate of birds to their breeding site. And they decided this would be a good population to use geolocators on. They used 100 geolocators and they retrieved 3. So a very poor result from which you can't make any very convincing deductions. Now, this story of the woodland kingfisher involves Warwick Tarboton very directly. This pair of woodland kingfishers had nested for several years in a nesting log outside his cottage in a place now known as Modimolle in South Africa, shown on the map. The coloring used on this map is unfortunately not very distinctive, but the interesting facet here was that the male and female were marked with geolocators, and they both came back the following year to their nesting log. The geolocators were retrieved, the data downloaded, and it was shown that they had both flown more or less due north, but the male had gone to the South Sudan and the female to the Central African Republic. So although these birds were a mated pair who had bred together for several years and came back to breed together again, they didn't spend the non-breeding period in the same area at all and appear to have moved quite independently while on migration. Now, a little detour to consider how birds find their way. They don't, of course, have access to maps and navigation systems, although the cartoon there of the homing pigeon studying a road map does show that when homing pigeons were followed in the UK, they found that many of them actually didn't fly in a straight line to get back to their home roost or coop. They actually followed the roads, so they were using convenient visual cues. We need to distinguish between 2 terms here. One is orientation. Orientation means just determining a direction. You orientate towards a sound. To actually navigate, you need to plan a route from A to B, and this requires a map and a compass. So you need to be able to determine where you are heading, and plot an appropriate route. So what cues might birds use? Because sailors have for a long time used sightings, the sextant, for instance, of sun and stars to determine their position, this was the first focus in looking at how migrants might find their way. Now, quite a lot of the early research was done using homing pigeons because they're readily available and well known. But of course, homing pigeons are not true migrants. But it emerged that yes, they can use sun and stars for their basic orientation, but they can't use them to navigate. Although they make allowance for changes in time of day and the position of the sun and stars, they don't use this in a way that enables them to determine their position on a map. So they lack the essential element, which is a very accurate clock, which was a key in human navigation at sea. So people wondered, do birds use magnetic fields? And this is, to me, always a particularly interesting example of the way in which science sometimes fumbles along and often needs a new approach, new equipment, new techniques to find the right answer. In the 1940s, there were some tests done on homing pigeons, and they were tested in strong magnetic fields. The thinking being, well, the Earth's magnetic field is a weak field. If birds can detect weak magnetic fields, you should get a much clearer response to a strong magnetic field, thinking of how human instruments would react. And they got no response. So the conclusion drawn was, well, they don't detect magnetic fields, so we'll go on and look at something else. One of my favorite books is a book called The Hitchhiker's Guide to the Galaxy, which I hope many people have read. It's a sort of laugh out aloud book. There are many passages which are hilarious, ridiculous, and improbable in the extreme. But there's a famous section there where the great computer is asked to answer the question, solve the mystery of life, the universe, and everything. And at the appointed time, they report to the great computer, which replies 42. And everyone is appalled and says, but what use is that to us? And the computer replies, perhaps you should have thought more carefully about the question. And this is often the case in science. One should think carefully about the question. So the question actually posed here was, do pigeons detect strong magnetic fields? And the answer was no. They do not detect strong magnetic fields. But the question hadn't been asked, do they detect Earth strength magnetic fields? So some years later, the European robin was studied. And there are populations which are migratory. They're able to show very conclusively that these migrants altered their orientation in Earth strength magnetic fields when north and south, for instance, were reversed. They then flew in the opposite direction in a laboratory situation where they didn't have access to sun or stars, and this was the only cue available to them. They then had a look at pigeons again and did the obvious experiment where they sent pigeons out with little brass metal collars or magnets attached to them. And they found very interesting phenomenon that the birds with little brass non-magnetic collars, they orientated just as well on sunny days and overcast days. They were unaffected. The birds with magnets attached to them were fine under sunny conditions, but became, as the bottom diagram shows, completely confused under overcast conditions. So when they didn't have the sun available to them, they had to switch to magnetic orientation, and then the magnet interfered with the system. The question then was, how do birds actually detect magnetic fields? And they found some magnetite, little iron crystals in the beak of the pigeon. They thought, oh, well, that's the answer. And then over the years, they tested a number of different small birds, which could be conveniently tested in the laboratory. Here we see some examples from North America, from Europe, and from Australia, all of which proved to orientate in the same way and presumably using the same equipment. But then some experiments with the silver-eye, a little Australian bird, better known as a white-eye to many of us, showed that under red light, these birds became disorientated. And they suddenly asked the question, well, why does light affect magnetic orientation? And then earlier, there had been some suggestions from theoretical physics and chemistry that photopigments might be affected by magnetic fields. And then they looked again also at the pigeon bits of magnetite and realized these weren't connected with the nervous system in any way that suggested they were providing useful information. So they went back to the visual system. And this went back quite a long way. In 1978, theoretical physicists had written a paper suggesting that the pigments in the visual system could be affected by light energy, and they proposed what they called the radical pair hypothesis, that two different states were possible, and the magnetic forces would determine which state was established in these pigments. And it was all based on some highly mathematical calculations, sort of things which might frighten off the average biologist. So even though the paper was entitled Ways in which the title indicated this way in which living organisms might detect magnetic fields, it probably wasn't taken very seriously by most biologists who didn't read it because it's in the wrong place. There was no biological evidence. People questioned the sources. And there's this famous idea in science known as Occam's razor, where they say you should select the simpler explanation rather than the more complex one. So everyone went for something easier. This amusing illustration by one of the people involved in these studies simply pointed out that if you're dealing with an unstable system, a fly, for instance, landing on a block which is tilted could affect. So a small energy impact could well have a dramatic effect. And here we have one of the people who has written very extensively and whose writings I could recommend to anyone who wants to follow up on this area, Henrik Moritzen. He's a Dane who's currently working in Germany. And he went to took up a new post in Germany, having worked elsewhere. And he had a research station, these little wooden huts, and they were testing, once again, European robins. And they found that magnetic orientation, these birds was being completely confused. And they realized after some tests that this was due to a radio station, which was not too far away in the town. So radio waves, which of course are electromagnetic radiation on the same spectrum ultimately as light and other things, that these were affecting the behavior of these robins, and only once they insulated these huts did they have no interference with their experiments. By this time, investigations of the nervous system of birds had progressed to a level where it's possible to record in very fine detail in live birds without damaging them well, you do have to apply a little very fine electrode, but the bird is not being seriously injured or inconvenienced because brain tissue itself doesn't feel pain. So you can record from individual nerve fibers, and they found an area which is rather unimaginatively labeled cluster N. And the input to cluster N comes in from the optic nerve, from the eye. And you can both chemically and electrically disrupt nervous input to particular centers, only temporarily. And you find that if you do that, if you prevent input to cluster N, your magnetic orientation falls away. They can still use the star compass or the sun compass, so you're not knocking out that side of the visual system. But if cluster N is not receiving information, magnetic orientation falls out. They're also working in collaboration with colleagues in Russia who are working with European reed warblers. the first population they were working with was just near Moscow. These birds would be flying towards northern Scandinavia, which was their breeding area. So they then moved these birds 1,000 kilometers to the east. And clearly, to get to their breeding areas, they would now need to correct for this displacement. And they wondered, would they be able to do this? And sure enough, they were. And after quite a lot of work, they found that there is another magnetic system which is responding using information on this east-west displacement. So a map system, the input comes from a different nerve and different brain areas are involved. If you disrupt the input on this trigeminal nerve, the magnetic compass works, so north-south directions. The sun compass works, the star compass works, but they don't make this adjustment for east-west displacement. And this is still an ongoing area, so anyone can follow up on this. And sure enough, in the European robin, there's just a diagram of an eye, which you can see in any doctor's surgery, showing the input of light. And they found that there is an appropriate protein, which is most abundant in the migration season and is found in the cones in the retina of robins. So, just to recap about the magnetic field, 1944, you had experiments with strong magnetic fields, and the results were negative, and temporarily scientists concluded that birds weren't using magnetic information. 1965, experiments with Earth-strength magnetic fields concluded, oh, actually they are. In 1978, this radical pair mechanism was suggested by theoretical physicists, the idea that photopigments would be modified by magnetism. But in 1979, they found magnetite in the beak of pigeons and thought, oh, well, this is probably the sense area. But in 1993, they showed that light of different wavelengths influences magnetic orientation. Then synthetic chemists in the laboratory showed that photopigments do indeed respond to magnetic effects in the way that these physicists had predicted 30 years previously. And then re-examining the beaks of pigeons, they realized that these iron crystals there were unrelated to magnetic field detection. There was no nervous input. Then they found again that low-power radio waves disrupt magnetic orientation, and they were then able to demonstrate that photopigments found in birds are actually responding the way the physicists and the chemists had predicted. But then a little later, they found a second system for longitudinal displacement, east-west displacement, which is still under study. So new ideas, new theories, things which are neglected and then become relevant, and a very long and convoluted story. Now, just last year, I seem to be going a little over time here. I hope everyone has a drink in hand and time to listen. There was a review in a journal called Ornithological Applications by the main lead author was Iverson, so you can find this online if you want to. And they were looking at global positioning system, GPS, as opposed to what they call platform transmitter tags, PTT. They looked at a series of birds less than 500 grams, which were not available for the usual, were not subject of the usual satellite transmitter sets. They found 92 studies which met all their requirements. Notice only 4 of these in Africa and only 7 were in the Southern Hemisphere. The other 3 were in Australia. And they then looked at the success rate. GPS, where the actual tag was recording the information, you had to get it back. These are very small tags. They can be 1 gram or so, but the retrieval rate is less than 20%. So not a very good outcome. Where the GPS tag is transmitting, now this can be transmitted to cell phone towers, other fixed stations on land, there was a much better success rate. But this is restricted to areas where you've got enough receivers. So where you've got good cell phone coverage, you can use cell phone towers, but naturally many of these birds are moving over areas where the receivers are not necessarily available. So you're going to have lots of gaps. The best results were from the platform transmitter tags, which are sending the signal to the satellite, and it then has to be retrieved from there. The platform transmitter tags are becoming quite small, but there are extras in terms of sometimes solar panels and so on, and antennae. So they are still not entirely suited to very small birds, and particularly because they are arguing on the basis of comparative studies that the limit should be around 3%, less than 3% of the bird's body mass. Now let's just have a quick look at 2 spectacular examples, one of which is Southern African, one of which I acquired from this paper. Australian banded stilt is one of these waders that nests in very arid areas. They had platform transmitter tags, 5 grams, which were fitted to a 300-gram bird. These birds nest in the most arid areas of Australia. The redder the rainfall is highly variable and unpredictable, and it's also very dry. They found that over a period of 3 days, one bird moved over 2,000 kilometers. And you can see they are moving from coastal areas out into central Australia to areas where rain has fallen and suddenly breeding opportunities become available. So very interesting situation. The flamingos in Africa, we have some ringing data, which for a long time led people to conclude that with the greater flamingo in the upper picture, which has a pale bill and dark tip, below is the lesser flamingo, which has a dark red, uniform dark red bill. It is a slightly smaller bird. Greater flamingos were thought to have 3 main areas in Africa: East Africa, number 3, West Africa, number 2, 1 is the northern population, and Southern African. And it was thought that there was probably relatively little interchange between these. Lesser flamingo has populations in a more restricted area through Eastern and Southern Africa, along the coast of West Africa, and also a population in India. We had some indication from ringing results that there is actually interchange between these populations. But much more interesting data became available from satellite tracking lesser flamingos. These birds were marked in Southern Africa and South Africa. And one bird in particular flew almost immediately to Mozambique, so flew east, and then went to Madagascar and spent 2 years on Madagascar. So this confirmed what we have long suspected about flamingos, that they don't necessarily breed every year, that they may have long intervals between breeding episodes. And you can see there are very extensive movements through Southern Africa from this. Another bird which has been examined is the black harrier. which is very much a South African endemic. There's a small breeding population up in Namibia. The reddish points on the map here indicate areas where the first bird atlas, which was concluded in 1995, showed the birds to be present much more often than the current bird atlas, which started around 2003. So suggesting that there's a population decline. So once again, GPS tags here using fixed stations like cell phone towers were employed. We found a wide variety of patterns. Some birds remained in the West Coast area, which is where birds were caught and marked at their breeding sites, but a number of them moved very far east past Lesotho into KwaZulu-Natal and other areas there. So not only are they exposed to potential problems around their breeding sites where habitat change, fires, because they're ground nesting birds at the wrong time, and wind farms are a problem. They're also exposed to wind farm areas which are being established in many other sectors of the country. So once again, from a conservation point of view, knowing where these birds are going at different times of year and how to best try to assist these populations is a major factor. So let's think about what will happen in the next few years. Naturally, technology is advancing all the time. Tracking devices to actually follow from day to day small birds will undoubtedly be readily available in the next generation of biologists. Then there's a question of climate change. Can birds adapt? Will they be able to modify the timing of migration, breeding to match what is happening to the habitats that they are using? Will some populations stop migrating? That is also a possibility if conditions become uniformly warmer. Birds who stay at home will actually come to outnumber those who are traveling, and which birds will go extinct. For me, tracking devices to follow the sort of small birds I've worked with would be fascinating. We, for instance, would be very interested to know what swallows do on a day-to-day basis on migration. And the little bird down there is an example of that's a wood thrush, a window casualty, which is one of the factors which has an impact on many birds, obstructions which we have put up in their environment and which affect them in different ways and cause high mortality, are a very important element in population changes. So I hope that I've thrown out a few novel stories there, which you can follow up for yourselves. And if we have any time, I'll be happy to try to answer any questions. Thank you.
Thanks, Adrian. That was extremely interesting. I'm going to definitely look up some of those leads that you posted here. Your first question from Chris: how do godwits fuel their extended flights to New Zealand?
Well, they do lay up fat. Fat is a very good fuel. So these birds do lay up very heavy fat stores. And what we found for most birds, where they've looked at the speed of flight, is that there is a particular speed of flight where the bird will be most comfortable and will be using least energy. And that, in fact, seems to be the speed of flight that migrants typically use. So they're not going too fast or too slow. Obviously, they want to go fast enough to cover the distance within their fuel range. And they do seem to settle into the most economical speed. Some birds also, but I'm not sure that Godwits do this, some birds also fly temporarily high so they can use the jet stream at high altitudes. The downside of that is that oxygen is less readily available at high altitudes. So they tend to do this for brief periods and then drop down to lower levels again.
Thanks, Adrian. Okay, your next one from Lawrence. It's quite a long one. One of the South African roosting sites for barn swallows is at Mount Moreland, close to King Shaka International Airport. Over 10 years ago, I installed some noise monitoring equipment at Mount Moreland and 18 other sites, which was intended to keep track of aircraft noise, but also to study the impact of aircraft on the migratory birds. Does Adrian have any data to reflect a reduction of the barn swallows since King Shaka International Airport, or the impact of environmental noise and pollution on the migratory patterns?
I don't. I do know that birds are affected by environmental noise. An area that I have followed a little is the question of urban birds actually modifying the times that they sing and even the frequency of song in relation to the noise environment that they experience. So they certainly react to that. With barn swallows, there have been changes in the roost sites that are used, so that they certainly do shift roost sites for reasons which are not always obvious to us.
Thanks. And Lawrence also asks, has any concrete evidence been found regarding effects from 5G antennae on birds?
No, as I say, the evidence that electromagnetic radiation of various types, like radio waves and so on, does affect their orientation systems, but this is quite localized. And we've known in the past that there are, for instance, magnetic anomalies surrounding large ore deposits. So there are geographical sites where migration orientation is also disrupted by these. But fortunately, that seems to be quite a local effect. The general pattern with orientation seems to be that they use visual cues as far as possible. And the magnetic system is used to establish their initial responses to the visual cues, and then used as a backup when visual cues may not be available.
Oh, that's interesting. And then Colin asks, birds obviously lose water through respiration. How do long-distance, non-stop migrants deal with this?
Well, a lot of them migrate at night, and particularly in the case of migrants in Africa coming south from Europe, when they're flying over the Sahara, they migrate at night, and if they've lost too much water, they all haven't got enough fuel, they stop over at oases in the Sahara and spend periods resting in the shade and refueling before they continue. So yes, it's a very real factor for them, and they can be quite severely affected by bad weather conditions, sort of wind drift, which may carry them out too far, and then they are losing water at too great a rate.
Okay, and Angela says, what was the German word for migratory restlessness?
Oh, Zugunruhe. It's Zugunruhe. And it is a word you'll often find in the literature now.
Okay, and Peter asks, which bird does the longest annual migration?
Conventionally, that's considered to be the Arctic tern, because many of them breed well north of the Arctic Circle, and a large part of the population then spends their non-breeding season south of the Antarctic Circle. So they are reckoned to do about 20,000 Ks a year.
Okay, Mike Bridgeford said, bar-tailed godwits. For about 7 years, our summer quack counts indicate that numbers in Plet have gone from 5 birds to well over, I think that's 100 this year. Can you suggest any reason for this dramatic increase in these migratory birds? These are bar-tailed godwits at Plet.
At Plet.
Yeah, from 5 birds to 100.
Over 100.
Yeah.
There are shifts in populations. I know with the curlew sandpipers, it was shown many years ago that their populations visiting South Africa were very dependent on things like lemming cycles in their Siberian breeding grounds. So when there are lots of lemmings, the predators like the Arctic foxes don't eat as many ground nesting bird eggs as in other years. So when lemmings are in short supply, many nests are destroyed by the ground-based predators. But I don't know with the godwits. It would be very interesting to know which population these represent, whether it's a shift from birds from other areas that are starting to visit Southern Africa rather than a previous stopover point. But there may be people in Europe who would know the answer to that.
Yeah, that's fascinating, that dramatic increase in numbers. Okay, Angela says, the idea that pigeons use roads was very interesting. Would something like this have evolved with humanity, since we've been making paths and constructing roads for thousands of years? Also, do we know of any other human-made markers that birds use for navigation?
Well, they certainly use lots of visual clues, particularly over short distances. So homing pigeons are typically flown over areas close to their home coops, and they certainly are using mainly visual markers under those conditions. So they would be using any kind of landmarks, both rivers, streets, buildings even. They would probably use conspicuous towers and so on, and mountains, valleys, not only geographical features, but also definitely things that we've added to the landscape.
Yeah, what absolutely astounds me is how a small little swallow can come back to the exact same garden, to the exact same nest that it nested in last year. You know, that their GPS, their navigation systems are so excellent.
Well, okay. I think the navigation system gets it to the general area, and I think then it homes in by simple visual cues for the last bit of it. So, and
also memory. It must remember, you know, from last year where it was, and yeah. Okay, Colin, who asked about the godwits and the water, he's saying those long migrations from Alaska to New Zealand where they don't stop over and drink water. I think you said it spent 11 days in the air, non-stop migration. So is it true that their body organs sort of eat themselves, as it were, during migration, and then they've got to feed up again?
We know that for some of the other waders, I'm not sure if it's been demonstrated for the godwit, but I know for some of the waders from Europe, before they depart, the gut actually shrinks. It reduces quite dramatically in length, and this reduces their body weight, and then the gut regrows when they stop and start feeding again. So yes, there are, in some cases at least, major physiological changes. And we know from hibernating animals that they're able to reduce oxygen, blood flow, and so on input to particular areas of the body. So they maintain the crucial areas and effectively neglect other areas temporarily, just keep them at a ticking over level, as it were. And I'm sure that this physiologically is happening during migration, that key areas, respiration and blood flow to the muscles, are being prioritized as opposed to blood flow to many of the internal organs and so on.
Yeah, and they also shut off half their brain and sleep, they have like cat naps.
Yes.
If anyone wants to read a really fascinating book about bird migration, there's one called A World on the Wing by Scott Wiedensaw. It's a new book that I got at my local bookshop. I just couldn't put it down. It was so extremely interesting. I've written it here in the comments if anyone wants to try and find it. Okay, the next question, Peter asks, do Arctic terns fly non-stop? Which species flies the longest non-stop?
The longest non-stop flights we know of are definitely the godwits, because the Arctic terns can land on water, and they don't fly along the open ocean. They do hug the coastline, so they are feeding in coastal waters as they go along. So they are certainly stopping quite frequently. So,
yeah, I've seen Arctic terns at Cape Recife, so they do stop over on their way down to Antarctica. Okay, Elizabeth asks, do you have any information about how the war in Ukraine is affecting migration of European species? All the bombing and all that.
Well, I think birds would avoid areas where there's a lot of disruption and also air pollution, obviously, from the bombing. They would make small deviations, which I'm sure they can accommodate. I don't think there are any major stopover areas there, because that's quite early in the migratory system. But many years ago, over Israel, the Israelis actually had a big project investigating migration, because you do get concentrations of large birds, things like pelicans, eagles, and so on, passing over. And this is important both for commercial and military aircraft. So there has been in the Middle East for a number of years, a very good monitoring system of major pulses of migration through the region, and then informing aircraft of the altitudes at which these birds are flying, so that they can be redirected to avoid them.
Talking about Israel, there's a bombing there as well at the moment, and it's quite an important migratory route. Okay, Rosie asks, have you seen any evidence of migratory birds anticipating changing weather patterns to avoid I've got something over here. Hang on. I've got something over there. To avoid, indeed, use weather to aid migration.
They certainly
avoid-
do. They do take advantage, for instance, of wind conditions. So favorable winds to help them. So if you'd obviously want a tailwind in those circumstances, and they certainly make use of that, or will stop off and stay over under unfavorable conditions. But they're not always successful. There are many records of birds landing on ships out at sea, which suggests that groups have got driven seriously off course, and that the ones who landed on the ship are the lucky ones, that the others have already come to grief. So bad weather conditions can be quite disastrous for migratory populations.
Yeah. Lawrence, your comment about the rose-ringed parakeets, they're not migrants. They were introduced. They were escapees from probably from a cage, and the population's built up. So yeah, they're not migrants. Okay, last one. Rosie says, there was some work being done suggesting that sexual organs diminished in readiness for migration to non-breeding areas, not being required and aiding weight to a migratory bird. Fascinating idea. Has Adrian heard about this research?
Oh, that's very common in seasonal breeding birds. For instance, our local Cape weavers, the testes in a male will be about 12 millimeters long in the breeding season, and they will shrink to a diameter about 1 millimeter a few months later. So yes, that happens in migrants, but also in many other seasonal breeding birds, and the same pattern in the females, that actually in the non-breeding season, if you are examining one of these birds, a roadkill or anything, you may find it quite difficult to be able to identify the sex organs.
Yeah. Oh, that's fascinating. Yeah, that's the end of the questions. Adrian, that was really fascinating. Thanks so much. There are a lot of people saying thank you for your talk. It was absolutely fascinating. I've learned so much. Thanks, Adrian. Thanks, everyone, for attending. Yeah, we hope to get you back to talk on some other topic again, Adrian.
Well, be available, sure.
Good. Okay, thank you, everybody. Bye.